Science of Data on the Water Resource Optimization. Antonio Sotire Bordallo, Principal Professor, Technology of Information 1 and 2, MSc, Licensed Professor, Daniel Guillermo Caballer Riva, Associate Professor, Technology of Information 1 and 2, Licensed Professor, Emiliano Andrés Dueñas, Assistant Professor, Technology of Information 1 and 2, Accountant, Cristian Dario Ortega Yubro, Written Assignment, Chief, Technology of Information 1 and 2, License, Héctor Nicolás Sosa, Adscript Professional, Technology of Information 1 and 2, Martín Mauricio Villodas, my son, Helper Student, Technology of Information 1 and 2, Translator, María Mercedes Caballer, and others. Introduction. According to the characteristics of the Mendoza province in terms of relation of its water resource and the distribution of water supplies, it is convenient and fundamental to know the spatial and temporal distribution from those superficial water resources. It is said masses of water that always moves on the same direction, like rivers, streams, brooks, spring, etc., from which it can be made with the use of data science tools that contribute to the Earth analysis when an inherent effect of economic science. The water resource of the province of Mendoza can be analyzed with satellite images and with them develop different models using learning algorithms, achieving the precise information that contributes to the decision making and supports valuable knowledge to start to value more the water and project those results on productive metrics of the province. The conjoint of free historical data are obtained from the Google Earth Engine application that allows to build different models that provides evidence of state and the ecotone changes that indicates the area of transaction between biomes, like for example the changes of surface with water and surface with no water. We need to have in present that satellite images possesses spectrums that are not visible, such as infrared band and nearby infrared band. Each pixel of these satellite images has a reflectance value. The reflectance indicates specific characteristics of the images. With Python and the algorithm application and mathematical operations can be classified those different pixels from the satellite images from a selected point in virtue of the observed characteristics and perform such classification.
Let's see a practical case using Google Colab with Python. The example can be consulted in the GitHub repository, following the document link. We are going to access a set of satellite images. The images will be from the Landsat 8 collection. This collection has the composition for the NDWI index. We define the variables necessary to load latitude and longitude. In this case, we select latitude and longitude of Petrarios, and we use a map layer called Folium. On this map we will place the Google Earth Engine satellite images with the NDWI index dataset. Can detect surface water changes. Until now, we have accessed the satellite image dataset, and we will apply the necessary filters for the images. Then we visualize the coordinates in the Folium map layer. And with a specific algorithm, we achieve the NDWI index. Subsequently, with a series of time differences in surface water can be observed.
Conclusions. The data catalog available from Google Earth constitutes a continuous monitoring of satellite images from high resolution from the entire Earth. With the coordinates expressed in latitude and longitude, it can access to a collection of images captured with different sensors, expressed on the different satellite bands emerged from data collection at sea, and the tools that it's been using to get those images. This band supplies characteristics to images, and its correct performance generates a very valuable information. With the images, it can generate models that allows the water resources. Those models can be based on the NDWI index performance. The vegetation from a determined surface zone is seen submitted to a severe stress during the drought. If it's not defined the affected areas on time, the whole crops can result damage. The early detection from water stress can prevent a lot from the negative impacts on the crops from a determined region, more even in our province by how vital that is the water in Mendoza, since Mendoza is literally a desert. The remote observation from Earth through telemeditation and the generalization from NDWI index can, between other profits, control the risk of the province in real time, improving significantly the agriculture, especially in areas where it is difficult to satisfy the water needs. It can also locate masses of stocked water, providing the access to such areas to make the necessary work that avoids the bug's proliferation. Therefore, the gain data about the satellite sensors that is being detailed previously allows to project the evolution of hydrographic variables, allowing to process from the way measure information from the take of strategic decisions and optimize the water resources of the province of Mendoza. Such decisions can be associated, for example, the environment damage from the province, the availability of water from consume, the availability of water for irrigation, and the water planification, among others, evidencing with the following investigation job that such data can be under requirement for any person that possesses a Google account, Python installed on their device, Wi-Fi connection, and aspiration to investigate on the following thematic. Projections. The projections that sees are multiple and very valuable. One of them is the recompilation of information in base to the conclusions from the application from indexes, and pour those conclusions on the generation and projections from the productive matrix from the province of Mendoza, from which the relation to the economic science from data science is more than narrow. Even though a punctual projection from the following work must interfere on the points that are detailed here below, that are defined in virtue of have reached the goals that were formulated for the backbone, and those points are generate complementary indexes to NDWI, process gain information with Panda and NumPy, apply specific algorithms that allows to associate data with TensorFlow, from which the TensorFlow application implies inherently the generation of an automatic learning model. If expressed previously, some study utilization of catalogs from Google Earth Engine data. A support of the analysis of Earth science allows the generation of several lines combined from applicable studies to the economic science according to the next data conjoined. It can conclude that the projections of further investigation will imply a job conformed by a multidisciplinary team with no more integrant. The conjoint of data to those that can access nowadays are classified from the next way: climate and time, temperature from terrestrial and marine surface derivative from several sensors of spaceships, climatic models to generate predictions in long terms, and historical interpolation from variable from surface. The catalog from Google Earth Engine includes historic data, meteorological data, and outputs from climatic models and climatic projections from Earth Exchange in ESA, atmospheric data to help to correct images for data from other sensors, meteorological data that describes the predicted condition and measures in short periods of time, including the precipitation, the temperature, moisture, and wind, and other variables, analysis of satellite images, collection of Landsat images that is a conjoined program from USGS and from NASA, collection of sentinel images through the Copernic program. That is an initiative headed by the European Spatial Agency (ESA) that includes images of radar from all climates. Moody's images collection through Earth and Aqua satellites from NASA has been acquiring images from Earth daily since 1999, including daily images, surface reflectance, and derived products as vegetation index and snow cover. Any questions?